So as three circles are arranged as shown, if AG is 4, GB is 5, find the area of the shaded region. Okay, without wasting time, the answer is 9. Yes. So the first thing I will do is to show that the area shaded is equal to area of the triangle ADB. Yes, that's it. And also, by geometric mean of triangle, prove that DG is equal to square root of AG times GB. So with that, you see that our area, therefore, area of this triangle ADB is half, the base is AB, and AB is 4 plus 5. That's half base times DB is now is DG, which is the height, times the height. The half base times the height is now square root of AG. AG is 4 and GB is 5. So do you see the answer? The answer is square root of 4 is 2. 2 into, so we have 9 root 5. So option C. So the key thing is this and this. So I'm going to prove these two. That was what made this solution to be simple. So the first thing I'm going to show that BE is equal to square root of AE times that of that. So let's call this to be X and Y, and this is H. So I'm going to prove that H is equal to square root of X times Y. So the idea here is this similar triangle, because we'll call this this is called geometric mean of triangle. We'll call it is one of the, it has 3 formula: geometric mean of triangle. So if you notice, we have 3 right angle triangles here. Yes. So triangle ABE, triangle DBE, and finally the big one ABD. So if I call here theta, here is 90 minus theta, because we have 90, and here is now theta. Why this is 90 minus theta? So we have 2 right triangles that are similar. I'm comparing, saying that triangle ABE is similar to triangle BDE. Yes, by right triangle similarity theorem. So which implies that H, remember 2 triangles are similar if the ratio of their corresponding sides. So for this triangle, for this small one, H, as you can see, 90 minus theta is opposite H. So which of the side is opposite 90 minus theta? Y. So we have H over Y is equal to X of that same small triangle. Do you get? I'm comparing 2 sides. H corresponds to Y in this triangle. YX corresponds to H in this one. Yes, because if you can see, X is opposite theta, H is opposite theta. So that's why the 2 triangles are similar, which implies that H is now square root of XY, which is what we've proved. So this is one of the geometric mean of triangle. So let me prove the other 2 so that you learn once. So we can still compare triangle, the small one, that is ABE. with the big one, triangle ADB. So I'm comparing this small one with the biggest, that's the largest triangle, which implies that, so the ratio of the side, okay, let's call here A and B. You can see that A of this small triangle is opposite 90, while x plus y of the big triangle is opposite 90, and x of this small triangle is opposite theta. Why the big triangle? Which one is opposite theta? A. Therefore, A is now the square root of x times x plus y. So that's the second. This is the first geometric mean. This is the second geometric mean. Finally, the third one, we'll compare the small triangle, that's this one, this side, the one on the right hand side, with the big one. So we see that triangle BDE is similar to triangle ADB. So we're comparing this one with the large one again, which implies that B over x plus y, that is B of this, is opposite 90, so also x plus y of the large one is opposite, is equal to y over what? B. Therefore, B is now square root of y times x plus y. So that's the third geometry. So we have 1, 2, 3. So these are the formulas. If assuming you are giving x and y, you can get B as long as this is 90 and this is 90. So we have the same diagram. So let's prove that the area of the shaded region is the same as the area of the triangle. So if we call, okay, let's call here the area here A1, and this small part, let's call it A2. Let's call the area of the triangle A3, and this A4, and finally A5. So we have total of 1, 2, 3, 4, 5 regions here, and we're asked to find the sum of A1 and A5. So we want to get A1 plus A5. Looking at this, you see that A1, to get A1 is A1 plus A2 minus A2, as you can see, which is correct. So if I want to get this area, you subtract this from the total area, which is A1 plus A2, plus that same way, if I want to get A5, A5 is the same as A4 plus A5 minus A4. Yes. And looking at A1 plus A5 is the area of the semicircle, while A5 plus A4 is the area of that. Okay, let's do it this way. This is A1 plus A2 plus A4 plus A5 minus A2 minus A4, which is the same as A2 plus A4. Yes, do you get the logic? This minus A2, this minus A4, so we'll factor the minus sign. So with this, we can see that A1 plus A2 is the area of this semicircle. Okay, let's continue. We can write this as A1 plus A2. Just repeat this and this. But if you look at A2 plus A4, is the same as the area of this semicircle minus A3. Do you get? A2 plus A4. The sum of this area is the same as subtracting the area of this triangle from the area of the semicircle. So I'm saying that is now minus A2 plus A4 is the same as A2 plus A3 plus A4 minus A3. Yes, if I want to get the sum of this and this, is the same as the area of this minus A3. Okay, we can write this as A1 plus A2 plus A4 plus A5 minus A2 plus A3 plus A4. That's minus times this plus A3. Yes, we just open this bracket. Minus times all this is this minus this. Why minus times that is now. So we can see that this means area of the semicircle, the first semicircle. This means the area of the second semicircle, and this means the area of the third semicircle. So you know area of semicircle is half of the area of a circle, which is half pi. The diameter is AD over 2 all squared. Do you get? Because AD is the diameter. So the radius is now AD over 2 plus this is the area of this one. This is also half pi. The diameter is dB, so dB over 2 all squared minus the semicircle here. This is half pi AB over 2 squared plus area of this is half base times height, which is half AD times dB. So we can factor, let's focus on these three. If we factor pi over 2, we are left with AD over 2 squared plus dB over 2 squared minus AB over 2 squared plus half AD times dB. So this is pi over 2. As you can see, this is AD squared over 4 plus dB squared over 4 minus AB squared over 4 plus half AD dB. So this is equal to pi over 2. The LCM is 4. So we have AD squared plus dB squared minus AB squared plus half. So what do you notice? This is 0 because from Pythagorean theorem, AD squared plus DB squared is equal to AB squared. So from Pythagorean theorem, this is equal to AB squared. So AB squared minus AB squared is 0. 0 times pi over 2 is 0. So we are left with half AD times dB. So that's how we got the formula that, and